There are further and further research questions that make visual cognition an interesting topic of research. Consider this image now. In this image, you see several buildings. Let's think about their orientation with respect to the image frame. Compared to the upper and lower horizontal borders of this image, the buildings look tilted. So if I were a dummy AI agent, again, I would assume that these buildings are skewed or even bent. Indeed, the life is still difficult for this robot agent because one of the buildings is really skewed. For us, it is easy to perceive them as buildings that have usual and expected geometry. We don't think that these buildings will fall because they do not look vertical to the ground. So these situations tell us that we should have some expectation about the visual world around us. So for instance, we expect that building walls are mostly vertical with respect to the ground surfaces, and the ground itself is in most cases horizontal. Also think about our offices, where the floor and the ceiling are unsurprisingly horizontal and the walls are vertical too. Well, the majority of large visual objects around us have either horizontal or vertical edges. Let's try to think about visual properties of these objects further. For instance, what does an edge mean? At first it seems to have a straightforward answer, but that is not the whole story. Consider this cylinder. Does it have edges really? It is eventually a three-dimensional shape with no sharp edges that are vertical in this picture. But look, that is indeed not a cylinder. It is a two-dimensional image of a cylinder. What makes us think that it is three-dimensional? In the previous lecture, we said that we need the knowledge of objects to be able to perceive them as complete objects. Remember the parking lot example that was full of cars, which were of course not incomplete, but they looked incomplete. It is then evident that without previous knowledge of objects, it is not quite possible to perceive them as complete objects. Is it also necessary that we should have the knowledge of an object to be able to perceive it as a three-dimensional object? So this is not an easy question to answer at first glance, but it is indeed not necessary. Otherwise, we would not be able to perceive novel objects. But more generally, the perception of depth in a three-dimensional picture is related to the pattern of light in the picture, its reflections, and its intensity profile, as well as other cues that make us perceive depth. One of those cues is about size constancy. When the objects move and they get farther away, they look like they're getting smaller, but we do not think that they are really getting smaller. So what would happen if they really, physically would get smaller? Maybe you would end up with a visual illusion. So we will talk about visual illusions later. Coming back to size constancy, it is one of the principles of visual cognition in that we easily detect if the changes in the size of an object is due to changes in its distance to us. There are further interesting questions about visual cognition. Consider movement. Suppose that you travel in a train. The visual scene around us continuously changes. Now suppose that instead of the window, you have a large screen which displays the same changes in the visual scene as a movie. In terms of the images projected onto your retina, which is basically the surface at the back of the eyeball, the representation of the visual scene is the same in both cases. How do we make sure that we are moving but not the visual scene, and vice versa? There are many questions as such in visual cognition research. So in the next lecture, we will think about where to find the answer. Is it in the light, in the eyes, or in the brain, or maybe in our personal experience about the visual world?